Hey, so thanks so much for the invite. It's a real pleasure to come and talk to you today. So I'm going to be talking about access problems and I guess, some stuff up from more from the cognitive sciences studies of very basic numerical abilities in kind of infants and animals and sort of, I guess, basic mathematical abilities of ordinary folk, and then think about how that might point to very different ways in which we might try and have a naturalist approach in the philosophy of mathematics. So just a brief overview. I'm going to talk a little bit about access problems. So some of you might be familiar with Benacerraf's kind of more famous access problem. I think there are quite a lot of other access problems in the vicinity. So I'll just mention those and why I think they bring up real tensions for different types of naturalist approach in the philosophy of mathematics. And then I'm going to talk a little bit about these two different ways you might be a naturalist. So Bart van Kerkhoven's got this nice distinction between internalist and externalist naturalism, yet another internalism versus externalism distinction in philosophy view. Then I'm going to talk a little bit about some of the work I've kind of looked into on numerical perception. I'll try and do this at a pretty zoomed out kind of, not get too into the messy details of the psychology here, just to try and motivate this idea that there is such a thing as numerical perception. Then I'll move on to why I think this actually has some interesting implications for the kind of philosophy of mathematics, and talk a little bit about this notion of metaphysical parity that comes out of this, and then return to this idea that this really points to sort of divergences in the kind of verdicts you're going to get depending on what kind of naturalism you kind of think is the right way of approaching mathematics. If you think we should be a naturalist, maybe if you think might be a good reason to not be a naturalist if you think these tensions are kind of insurmountable. But either way, hopefully there's some interesting things kind of in what the methodology should be really when we do philosophy of mathematics. So just a little bit about my own background, kind of as I've already mentioned a bit. I mean, I started a lot of my work was very much in the philosophy of mathematics, trying to see if any of the findings from the study of numerical cognition have any interesting implications for epistemological and metaphysical issues in the philosophy of mathematics. But nowadays, as I kind of mentioned, I kind of work more on philosophy of psychology, philosophy of imagination, and philosophy of modality. And I haven't presented these kind of ideas for at least a few years. And this, I mean, maybe this is part of a made-up story, but it might partly be because when I once went to an eminent conference of one of the most, I won't name them, but a very, very famous philosopher of maths who I was quite in awe of, said, well, what does any of this stuff about numerical perception in infants and animals have to do with transfinite cardinals? Why is this even interesting to philosophers of mathematics? I mean, part of me was just very demoralized about that, which might be sort of put me off working on things in a bit. But I think, there is actually some really important question there, and actually whether it's possible to bridge a gap between these studies on mathematical cognition and the kind of things that mathematicians, both professional mathematicians and philosophers of mathematics are interested in is really interesting. And I'm going to try and say that there might be, but it might be really hard. But at the same time, I did think the question was slightly unfair, right? If I'd given a talk about infant object perception and a philosopher of physics had said, well, what does this have to do with quantum mechanics? You might think that's a little bit unfair. So I think, although sort of in some ways that kind of attitude put me off working in more mainstream philosophy of mathematics, I think they are really indicative of important tensions when it comes to what a naturalist approach to mathematics might be, and that's what I want to explore today. So sort of a lot of my early research was focused on Benacerraf's access problem, and I'm going to give you a sort of as brief a summary as I can of that initial access problem, just so that we're all on the same page with it. So Paul Benacerraf, in a famous article, argued that there are sort of 5 intuitive ideas about the nature of mathematical knowledge which end up being mutually incompatible, or kind of mathematical semantics and mathematical knowledge and the implications for ontology. So firstly, I mean, it seems pretty hard to deny, at least for many, that most widely accepted mathematical claims are true. Secondly, there's this idea that we should have a unified semantics for mathematical and non-mathematical claims, and kind of within that, a unified semantics within mathematical claims, which will be important later. So the idea here is, if I say 3 is prime, or I say there are transfinite cardinals, those things, if they're true, commit us to the existence of things like natural numbers or transfinite cardinals, in the same way as if I was to say cats are mammals, or I was to say that Higgs bosons exist. Those claims also commit us to the existence of the entities that are mentioned as long as those statements are true. Now, obviously, you might have a very different semantics where you think none of these things commit us to anything, but the idea is that there has to be consistency in how we interpret mathematical and non-mathematical claims. We shouldn't treat mathematics as some kind of a special case when it comes to the meanings of our claims. Thirdly, we've got this important step, which is going to be maybe the thing that gets sort of most challenged by the other kind of views of naturalism I look at today, which is that if mathematical entities do exist, then they're abstract entities. So they're causally isolated and inert, right? They're not the kind of thing that can cause things or be caused by stuff in the physical world.
Max, sorry, just a question. Are you moving through the slides?
Oh yeah, is that not working?
No, I'm just still at the first slide.
Oh right, okay.
Can you just, okay. Now I can see the fourth slide or the fifth slide. Yeah.
Okay, yeah. Well, I'll just do it in this mode then. That's probably easier because then I can see you all as well. So yeah, sorry.
Okay.
Yeah, because obviously the full screen mode didn't work on this. Okay, that's fine. Right, yeah. So these are the things I've been talking about. Sorry. Yeah. So then after that, we get this claim that for a subject S to come to know about a subject matter X, there must be some causal connection between S and X. So this is, you know, a standard causal theory of knowledge. And finally, we get a kind of relatively straightforward claim that most people, I assume, wouldn't disagree with, which is this: at least some of us have some mathematical knowledge. Now, when it comes to Benacerraf's access problem, one of the ways in which people have kind of often thought the easy response is just to give up on a causal theory of knowledge, right? I mean, there's loads of different theories of knowledge out there, and the causal theory of knowledge is quite it's not something that most people are wedded to. But I think there's something deeper going on here, and I think just getting rid of a causal theory of knowledge and trying is not going to work. So there's this nice quotation by Hart. Can you see? Does it move slides there? Just to check.
Yeah, I for me, if you went to the next slide, so yeah.
Yeah. Okay, so yeah, Hart says it's a crime against the intellect to try and mask the problems of naturalizing the epistemology of mathematics with philosophical razzle-dazzle. I don't really know what he means by that, but it's a nice phrase. Superficial worries about the intellectual hygiene of causal theories of knowledge are irrelevant to and misleading from this problem. For the problem is not so much about causality as about the very possibility of natural knowledge of abstract objects. And this is something I really agree with. I go into a lot more detail in other work. But I think that, you know, there is something much more deep going on than just this idea of causality being a problem. And one way we can get at this is through Hartree-Field's kind of beefed up version of the access problem. So he again argues that it's not really just a thing to do with a causal theory of knowledge. Benacerraf's access problem doesn't really challenge our ability to justify our mathematical beliefs and sort of try and explain the justification of our beliefs in terms of something to do with causation. It challenges our ability to explain the reliability of our mathematical beliefs. So Field puts it like this: Benacerraf's challenge is to provide an account of the mechanisms that explain how our beliefs about these remote entities can so well reflect the facts about them. And this is kind of getting towards the kind of view that I'm interested in, right, where to really answer this challenge, we are going to need to think a little bit about the cognitive sciences and really treat knowers as mechanisms that we can explain. And this is going to be difficult as long as we're wedded to the idea that mathematics is about these causally inert or sort of remote mathematical entities. And really importantly, it's not just a problem when it comes to knowledge, right? So Lear and Hodes both point out that there's going to be similar access problems, even for explaining our capacity to successfully refer to mathematical entities. So at least on quite a lot of views in the philosophy of language about the nature of reference, there are a lot of people who are wedded to some kind of causal theory of reference. I mean, those of you familiar with that might think of things like the Kripke-Putnam style causal historical theories, where you at least need to be in some kind of causal relation to some act of baptism around the entities you're talking about. But in those cases, again, if we're not causally related to, or there's no obvious kind of mechanistic relation between, or physical relation between us and the mathematical objects that we're supposedly talking about, how can we successfully refer? So again, we've kind of got this similar move. Even if you avoid a causal approach to reference, you might think we can make a similar move to Field and question how we can even explain in kind of naturalistically acceptable terms our reliable, successful reference to mathematical entities. Now, I think, one of the things that is worth considering when we've got these two sides to this, where both reference and knowledge seem to be problematic for mathematical entities, is that maybe there's some underlying issue. And I think one thing we could try and look for here is thinking about what knowledge and reference have in common. You might think, look, both knowledge and reference to mathematical entities depend on a subject having beliefs about those entities. That seems relatively straightforward. And having a belief about mathematical entities depends on possessing mathematical concepts which are about the entities in question, right? So in the end, what we really need is some kind of naturalistic explanation of the content of our mathematical concepts. And I think this leads us to this kind of deeper problem, which is that when we then turn to kind of work in philosophy of psychology and philosophy of mind, most attempts to naturalize intentionality try and explain how we can have concepts that are about things that are independent of our minds tend to involve either causal, evolutionary, or informational relations between a concept or between a kind of mental representation of whatever kind you might have in mind and its content. So if you think about classical theories like Dretski's or Fodor's or Millikan's or Papineau's, all of these seem to require one or more of the causal, evolutionary, or informational relations. But the thing is, none of those relations seem to be viable on the assumption that mathematical entities are abstract in the sense of these things that are kind of isolated from us with no spatiotemporal location and no causal power. It's quite clear on that, just by definition, really, that abstract mathematical entities can't be the causes of our concepts if we go for a sort of simple causal theory of naturalizing intentionality. I don't think there are that many people that still subscribe to such a kind of simple approach, but nonetheless, it doesn't seem that, it seems pretty clear that things that are merely abstract can't impact on an organism's chances of survival or reproduction. So it's not going to be useful for an evolutionary explanation. And arguably, it's kind of hard to see how information from some abstract mathematical realm could be kind of transmitted to the physical realm, insofar as we think there are kind of relationships between information and energy transfer. So this all of these different access problems point to this idea that we really struggle to come up with a kind of naturalized epistemology of mathematics, as long as we're wedded to a kind of Platonism or some view of mathematical entities as abstract, whether that be a kind of more structuralist version or just standard Platonism. So we get this tension where it seems like a naturalist ontology points towards abstract realism about mathematical entities. It might be that we get this naturalist ontology by appealing to kind of Quine's ideas about indispensability. So it's the role of mathematical entities in science that leads to us believing that they exist as abstract entities, or it might be more just deference to mathematicians' expertise, like that's advocated in Penelope Maddy's recent work, for example. So we've got this idea that on the one hand, if we kind of want to be naturalists who defer to the scientists or to the mathematicians, we get given an abstract ontology, but then this abstract realism about mathematical entities seems to undermine the possibility of a naturalized epistemology of mathematics, where we can really explain how mathematical cognizers are able to gain knowledge in a way that fits with our contemporary sort of best theories in psychology and the cognitive sciences. Now, it's worth noting that the standard view of naturalism is to kind of start from this ontological point of deferring to the scientists or the mathematicians, and the access problems arise from taking this ontology first approach, and then we encounter those problems. So it's worth considering whether there might be another way, perhaps starting instead with a naturalized epistemology. So this brings me to this nice, useful distinction from Van Kerkhove between internalist and externalist versions of naturalism. See, as I say, Van Kerkhove distinguishes between internalist and externalist ways of developing naturalism. And I guess, I sort of feel a bit bad about bringing up yet another internalism versus externalism distinction, because there's sort of too many of them already in philosophy, and they all have slightly different nuances to them. But I do think this is quite useful. So the idea is to think about internalist versus externalist epistemology in the individual case. And this distinction is going to mirror that kind of distinction, but for whole disciplines. So very roughly, the idea is the internalist approach is about we tell whether something is mathematical, sort of, well, we infer kind of views about the nature of mathematical knowledge and mathematical ontology by deferring to people within the community, right? In the same sense as in the individual case, you know, we decide whether something's knowledge internally within our own minds. Whereas the externalist view is to kind of take a step outside the mathematical community and study the processes that give rise to mathematical knowledge within that mathematical community, kind of in the way an animal behavioral scientist might study the processes going on in some species of animal or something like that. So I think, you know, just to kind of go into a bit more detail here, I think if you get too annoyed by more internalisms and externalisms, I've given them slightly different names, so that helps. So I think for the internal naturalist or internalist naturalist, you could also call deferential naturalism. This takes the practitioners of a particular discipline, so in this case mathematics, to be authoritative with respect to the ontological status of the subject matter and the means through which they acquire knowledge of that subject matter, right? Very simply, if you want to know what mathematics is about and how people know about it, you should ask a mathematician. So in this case, the ontological commitments of scientific and mathematical theories tend to be taken at face value, and the reliability of knowledge acquisition is assessed kind of introspectively, or at least intradisciplinary amongst those mathematicians. You know, we just ask them. This, I think, you can kind of see in two big strands within the philosophy of mathematics. So either you get the kind of Quine-Putnam indispensability arguments and their various successors, where we ask the scientific practitioners, well, we read off the work of scientific practitioners, what they're ontologically committed to, and it turns out they seem to be ontologically committed to mathematical entities. And in Penelope Maddy's later work, we can see a kind of more, perhaps more extreme version of internalist naturalism, where we should see mathematics as methodologically independent, and we should defer to mathematicians and what they say when it comes to both the ontology and how mathematical knowledge is generated. But that's not the only approach available, right? Instead, we could adopt what I'm calling here externalist naturalism, or you might call it ethological naturalism, with this eye to sort of treating mathematicians as you might go about treating some sort of other species if you're trying to study them without knowing much about what it's like to do mathematics. And this takes a kind of different scientific approach to studying the practitioners of a particular discipline by investigating the behaviors and underlying mechanisms that support their knowledge gathering abilities. And this is important, you might think, because perhaps, you know, we don't necessarily know about how we know purely through introspection. It might turn out that while mathematicians might be excellent at gaining mathematical knowledge, they might not thereby be excellent at gaining knowledge of how one gains mathematical knowledge. So it might be that instead of mathematicians, if we want to know about how mathematical knowledge arises, we should appeal to specialist disciplines who study human and animal mathematical cognizers. So appeal to disciplines such as psychology, anthropology, cognitive science, neuroscience, ethology, biology, and the broad kind of studies into mathematical practice. So you might kind of think this is a kind of more bottom-up approach, whereas rather than a top-down approach, where we investigate the whole spectrum of mathematical abilities, interested in all mathematical cognizers, rather than just asking the expert practitioners how they come to their knowledge. And this can be seen in a broad recent trend. I mean, there's the whole over the last 30 or so years, resurgence of interest in mathematical practice, and even more recently, attempts to apply findings from the sort of cognitive sciences and psychology regarding the nature of mathematical cognition. In particular, there's been work on numerical cognition and geometrical cognition to see if those have implications for our understanding of mathematical knowledge. And I think the interesting thing here, right, is that, you know, when we think about internalist naturalism, that seems to support this naturalist ontology first approach, right? This traditional view where we ask the practitioners of mathematics, insofar as they adopt some kind of commitment to the existence of mathematical entities, that's the starting point. That's what we defer to them on, and that gives rise to these access problems. But by turning to externalist naturalism, that might allow us to adopt a more naturalist epistemology first approach. And that might have interesting implications for how we assess these access problems. So that's what I'm going to now try and turn to, is try and make the case that we might get a slightly different perspective if we take an externalist naturalist approach. So I'm going to give you a sort of some quite loose arguments for the idea that we have a capacity for numerical perception, and hopefully you can kind of already see how this might have interesting implications for the access problems I mentioned earlier. So it's kind of, there's a lot of well-established work now on this idea. We have something like a number sense. We're able to rapidly apprehend the number of entities in relatively small collections without engaging in counting. Now, this is going to be reliably accurate when dealing with collections of 1 to 3 or 4 objects, and becomes increasingly accurate as the quantity increases. But you know, we still get a pretty good sense of how many objects there are for slightly larger collections. Has signature kind of effects like the size effect, where collections become harder to discriminate as quantities increase. So 20 versus 16 is harder to discriminate than 14 versus 10. And distance effects, where collections become harder to discriminate as the distance between quantities decreases. I mean, this is kind of obvious that it sort of seems like it's harder to distinguish 20 from 18 objects than it is 20 from 16. But these are important because they help to sort of suggest that there might be something closer to perception going on here. So this is, at least in part, arguably supported by a system in the brain known as the approximate number system. Stanislav Dehaene, the neuroscientist, has done lots of work on this, as amongst many others, but he gives a nice sort of overview of that in his book. So this is located in the horizontal intraparietal sulcus. It's arguably innate. It seems to be innate, and it's present in a whole load of other species. It represents seemingly an analog format. It's not necessarily conscious. In fact, you might argue it's kind of never conscious. It's some kind of subpersonal mechanism. It doesn't require sequential attention or counting. It's kind of immediate, and it represents number regardless of input modality. I mean, I want to be a bit careful there. We're probably not very good at counting smells, I think, but you know, so it'll work the same way whether you're counting beeps or dots or something like that, sounds or collections of objects. Now, this isn't the only system that's responsible for our capacity to rapidly apprehend the number of objects. Arguably, the object tracking system also plays a role. So this is consistently accurate when subitizing 1 to 4 objects. And there's a sort of step change in our behavioral performance when going from the range between 1 and 4 and beyond 4. So it suggests there might be kind of 2 systems responsible here. This is kind of a bit tangential, not too important to what we're looking at here. Just a couple of things to be said, really. One is that for this system, it has one representation for each object rather than having a representation of the number of objects in a collection. So it's not really clear whether we really want to call this a system that's dedicated to apprehension of number or numerosity. And it also plays this separate role of just keeping track of moving objects. Now, importantly, though, this doesn't eliminate the role of some people have argued that, you know, we only have accurate apprehension of numbers using this system. It doesn't eliminate the role of the ANS in our representation of number, because we can kind of distract the object tracking system using various experiments, and it seems like then the approximate number system takes over. So the performance with these small collections returns to what you'd expect if the ANS was solely responsible. So sorry if this is all a bit quick. This is just to give an overview for those of you who aren't familiar with this already. I think the really important thing that I want to point to here is that the way that these capacities are explained is remarkably similar to the way we explain various other perceptual faculties, whether it's kind of edge detection in vision or, you know, separate segmentation of sounds in hearing. It kind of fits all of the hallmarks of what you might call a kind of perceptual module within the brain, both in terms of its performance and its kind of physiological characteristics. So the way in which it varies, that was demonstrated by the size and distance effects, is in line with the so-called Weber-Fechner laws of psychophysics. So it's similar to other perceptual qualities such as brightness, volume, and weight. The performance of the systems is rapid and automatic and can be subject to priming effects. So it doesn't seem like we want to say that there's kind of anything like thought going on here. It does seem to work very similarly to other perceptual faculties. It's direct in the sense that it doesn't seem to be inferred from other spatial cues. So you might think that these systems, and this is slightly controversial, but at least arguably, you might think that these systems actually just work by, I don't know, summing the spatial extent of the things in front of one, but it actually does seem to be primarily sensitive to number. It can be subject to adaptation effects, which is another hallmark of various perceptual systems. And I've argued elsewhere that it can be understood in terms of perception of affordances for sequential action. So the idea would be that one of the roles of this system is to feed into action so that we can then engage in activities like sequential attention or counting, to verify exactly how many objects there are in a collection. So my kind of, I guess, sort of the bold and perhaps controversial claim here, but is just to say, well, if any attempt to kind of rule out this system as being a perceptual system, any attempt to kind of explain this system as giving us a non-perceptual apprehension of number is likely to also disqualify other faculties that we'd all sort of ordinarily qualify as perceptual as being perception. It'd be very strange if we if as a result of giving a principled reason to say this isn't perception, we also had to say that our apprehension of brightness or volume also didn't qualify as perception. So I think this is nicely captured by Dehaene's quote here, that number appears as one of the fundamental dimensions according to which our nervous system passes the external world. Just as we cannot avoid seeing objects in color and at definite locations in space, in the same way, numerical quantities are imposed on us effortlessly. Now, one quick kind of complication here is that often when the cognitive scientists are talking about our capacity for numerical sort of apprehending the number of objects in a collection, they will distinguish between what you might call numerosity and number. So along these lines, cognitive scientists distinguish between the concrete discrete magnitudes that animals represent, known as numerosities, and numbers, which are the abstract entities that are studied by mathematicians and philosophers of mathematics. Now, I along with various others in the literature, object to this distinction. Now, it's quite clear that if we have such a thing as numerical perception, it only imprecisely represents number. But that doesn't really seem a good reason to think that the thing it's representing isn't number. Right? So clearly our number sense fails to accurately capture the properties of the natural number structure, in that obviously 8 is not further away from 10 than 18 is from 20. But really importantly, approximate representation of number is not representation of approximate number. This goes for anything. Right? Approximate representation of any quality that is itself precise does not entail that the thing that's being represented is imprecise. So if we understand numerosity as approximate representation of number, then we represent number by representing numerosity. And this is supported by Clark and Beck, who say that from the premise that the ANS represents imprecisely and the premise that numbers are precise, it simply doesn't follow that the ANS fails to represent numbers. Think about other things like weight. The fact that I can represent someone's weight imprecisely by saying, roughly as heavy as a linebacker in the NFL, that doesn't mean that there isn't a fact of the matter about the precise weight of that person. I think another important thing, more relevant to the context of this talk, is that our number sense sort of seems to represent properties of concrete collections, but on many others' assumptions, number is abstract. Notice that kind of is assuming this kind of internalist naturalist approach, kind of whether or not number is abstract should be up for grabs. So from an externalist naturalist perspective, we can't help ourselves that yet. So I think there's another quote from Clark and Beck, that no one has any idea of what numerosities are meant to be. It's better to say that the ANS represents numbers of a familiar sort. Okay, so that was a kind of very brief overview of some of the reasons you might think we have a perceptual faculty for apprehending number. Now I'm going to have a little look at what this might mean for our kind of ontology and our metaphysical picture, at least of, very important to note that it's only going to have any impact on what we think about very small numbers, right? You might think maybe the esteemed philosopher of maths was right to think this doesn't have much of an impact on philosophy of maths, and I somewhat agree, but we'll get to that. Okay, so many of you might still be unconvinced about all of this stuff about numerical perception. Let's leave that aside for now and just suppose that the evidence from the cognitive sciences supports the case for numerical perception. What would that mean for the access problems? So it seems as if, look, at least some of our epistemic access to some mathematical entities, very few, the first few natural numbers in the natural number structure, is on a par with many other physical properties, right? We can acquire some number concepts perceptually. So it seems like the findings from the cognitive sciences, at least at face value, are in conflict with a key part of the reasoning behind the access problems, right? That we can't acquire any knowledge of any mathematical entities through normal causal interactions in the physical world. And I think part of this is this kind of assumption that this stems from the assumption that if mathematical entities exist, they've got to be abstract in the sense of being causally isolated and inert. So another way of getting at this is that a key assumption of the reasoning behind the access problem is that there being a metaphysical disparity between the objects that we supposedly are trying to know about, the abstract mathematical objects, and the physical cognizers entails a disparity in the possible epistemic access to the mathematical entities. But if that came about from starting from this internalist naturalist position. If instead one starts from the externalist naturalist perspective I've been advocating and addresses the sort of epistemology questions first, then it seems the problem is flipped on its head, right? The access problem looks very different. Because instead we might start from the parity of epistemic access between some mathematical entities, a few of the early natural numbers, and other perceivable properties, and then infer a metaphysical parity between the two of some sort. So if it's the case that that we access some numbers perceptually, then we should understand numbers to be in some sense metaphysically on a par with other perceivable properties. Now, at first, this might sound like an extremely radical claim, right? The idea that we might have perceptual access to mathematical entities is quite radical. I mean, there were some around the sort of early 90s, late 80s, there were some that advocated a kind of physicalist realism about mathematical entities. John Bigelow, Penelope Maddy in her early work that she then rejected. But I think it's really important to note that this isn't the obvious conclusion, right? Because that requires us to take a very naive perspective when it comes to the ontology of objects of perception. So I think there's a much weaker kind of claim, sort of in much weaker conclusion that we can glean from the kind of parity thesis that would come out from taking numerical perception seriously. Some numerical properties, not very many, should be seen as metaphysically on a par with some perceivable properties. But what that really means depends entirely on what ontology we have for the objects of perception. So in a way, the move from epistemic access parity to metaphysical parity is kind of neutral when it comes to the ontology of mathematics, independently of our ontology of objects of perception. Now, that can seem kind of a strange thing to say. I mean, you might think, well, it's really obvious that we think the things that we perceive exist, or they're just physical things that exist. But I think that's just, that only makes sense if you don't pay enough attention to the extreme levels of controversy within the metaphysics of perception. So, there's a continued and fraught controversy regarding whether we should be realist or anti-realist about colors. So if insofar as we might take numerical properties that we perceive to be on a par with colors, that doesn't decide either way whether we should be realist or anti-realist. So all we get here is the idea that really, in order to make a decision about the ontological status of some mathematical entities, given supposed facts about numerical perception, we need to pay more attention to how they're related to other perceivable entities and the ontology of other perceivable entities. In short, the ontological status of mathematical entities can't be understood in isolation from wider debates in the metaphysics of perception, and perhaps wider debates in the cognitive sciences around how perception works. Now, why does any of this matter? I mean, again, that you might think, well, it doesn't really. Remember that, you know, this is really just talking about some of the very early stages of the natural number sequence, and you know, probably most of even arithmetic is beyond any of the findings related to numerical perception. So you might think, really, this doesn't have much impact on philosophy of maths. But notice that most assume a unified ontology for mathematical entities, no matter how big or small. And this follows from this desire for a unified semantics, whether within mathematics or unified semantics with non-mathematical claims as well. We do tend to think that we should interpret 3 as prime in the same way as we interpret something like transfinite cardinals exist, in that both commit us to the existence of a mathematical entity. It seems strange to have one way of thinking about some more everyday mathematical entities and a very different way of thinking about others. Now, again, this is something we could give up on, but I think it's just worth highlighting that we get this, that there could still be quite significant implications for more sophisticated mathematical entities, even from considering these very basic ideas about access to mathematical entities among kind of infants and animals like crows. So start. So just to finish off, I'm going to zoom out a little bit and just think about these divergent naturalist approaches again. So arguably, if you buy into the kind of things I've said today, internalist and externalist naturalist approaches lead us to very different verdicts with respect to the ontology of at least some mathematical entities or structures. Internalist naturalism seems to lead us towards Platonism, where our access to mathematical entities becomes mysterious, whereas externalist naturalism leads us towards ontological parity between at least some mathematical entities and other objects of perception. This seems to suggest we need to pick a side, where we should either prioritize internalist forms of naturalism or externalist naturalism. But I think there are some avenues for compromise. So one option, it would be to sort of these views where we just accept perceptual access to mathematical abstracta. I mean, there's kind of reminiscent of some of Gödel's ideas, where he compares even sort of more sophisticated mathematical access to abstract mathematical entities to perception. Perhaps there's some way of making Gödelian notions of mathematical intuition compatible with these findings from the cognitive sciences. Another view, which I find fascinating, is this idea actually that we might just be wrong about perception, and actually really we should really explain perception in terms of perception of abstract entities. So Nicholas Goodman has a wonderful article where he talks about pool tables, and how actually when we perceive pool tables, we perceive them as planes and spheres on planes, and despite the fact there aren't really any spheres or planes in the world, so perhaps we only ever perceive mathematical entities. So that's kind of one route. Another option is to give up on this Benassarafian commitment to a universal semantics and a unified ontology. I mean, there's loads of different ways you might go about doing this. One option would be a kind of Aristotelian realism, where we just say, well, the mathematical entities that we can kind of perceive and we can count, they're one type, but eventually we're going to get to some kinds of mathematical entities that have nothing to do with the physical world, and we kind of have to remain ignorant about when we're talking about real mathematics and when we're talking about merely fictional mathematics. Or similarly, you could kind of go for something like modal structuralism of Hellman and say, well, it turns out that some of the possible mathematical structures actually exist, and all of our explanation of this perceptual access can be understood in terms of this latter point. And again, where the line between what's actual or merely possible in the mathematical realm is going to be something that's perhaps beyond us. I have a very different way of approaching this. I'm just sort of to advertise it, although I won't say much about it here, which is that I think we can maybe stop thinking about the subject matter of mathematics in terms of objects that we're committed to, and we might be able to bridge this gap by thinking about mathematics more in terms of the science of possible actions and explaining this numerical perception in terms of perception of affordances, which are kind of opportunities for action in the environment. So these are just some ways of potentially compromising, but I think, that they all have their problems. I think though there's a broader lesson to be drawn here, which is just that, look, a lot of the time, debates about metaphysics and ontology in mathematics are quite isolated from the rest of our debates about the metaphysics of the physical world and the kind of debates that go on in the cognitive sciences, particularly about perceptual qualities like color, shape, and things like that. And I think the internalist naturalist approach, where we just defer to the experts in the field, if it's done on its own, kind of engenders this far too comfortable isolationism regarding epistemological and metaphysical questions, when actually one of the benefits of externalist naturalism, whether or not you buy into the kind of story I've given you today, is that it emphasizes the need for more cooperation among the different debates in philosophy. So just to sum up, whether or not you buy into my specific arguments for divergence in ontology between these two forms of naturalism, it should be clear that the verdicts of the different approaches could, in principle, diverge. And while internalist naturalism is often taken to be the kind of default approach, with those who study mathematical practice or mathematical cognition seen as outside of the mainstream, this might just be because externalist naturalism is extremely hard work and there's a lot of work to do. We're just touching the very beginnings of how infants and animals are able to access number without really getting anywhere near the kinds of knowledge generation capacities that are indicative of professional mathematicians. So I think internalist naturalism shouldn't be taken for granted as the default approach. It needs to be defended. And if it can't, then we might have to accept there's a lot of hard work to do, really studying the way that mathematicians work, both the most basic mathematicians, whether it be bees or crows or infants, all the way up to the most sophisticated mathematicians working in university departments. And that might be what's necessary if one wants to be a naturalist about philosophy of mathematics, or if you think that's all too difficult, it's fine to just give up on naturalism. Thanks, everyone.
Thank you very much, Max, for your interesting talk. Other questions? Yes, see. Irina, you want to ask something?
Yes, hello
Irina,
everybody.
good to see you.
Hi, Max. Used to be my student in Bristol. Okay, Max, thank you for your talk. And I have a question about naturalism approach. How would considerations about AI nowadays affect this way of reasoning that you presented today?
Thanks, that's really interesting. And in other occasions, I've kind of talked more about the relation there. I think one of the difficulties, right, is that doing good cognitive science about expert mathematicians is going to be really difficult, partly because there aren't enough of them to get good data, and partly because there's likely to be a lot of heterogeneity between the different ways in which professional mathematicians actually acquire their knowledge. So I think one of the interesting things in the case of AI is that it might allow us to actually kind of do experiments that touch on the more sophisticated forms of mathematical reasoning that do go beyond the kind of just basic numerical perception stuff I was talking about today. Because yeah, it's very, very hard to get enough professional mathematicians together to get what a cognitive scientist or a psychologist would see as a kind of sufficiently good sample and to carry out experiments. So I think one thing that's important there is that AI could be used as a tool to kind of, and when we look into how AI is made in kind of things like AI proof systems, whether that be kind of all the various different types, whether it's the kind of more recent LLM ones or the more older ones, it gives us a kind of window into this that can be repeated and that can be intervened on. I mean, you can't sort of suddenly hit a professional mathematician on the head to see what happens to find out how it impacts their mathematical abilities, but we can kind of do that in if we test AI systems. So that's one area I think you can kind of maybe extend this externalist naturalism to be more fruitful than just getting this numerical perception stuff. One thing I would say that is quite interesting is that in an AI, and kind of separately in AI systems that were designed to do image categorization, they seem to settle on a strategy that seems remarkably similar to what we do in the case of numerical perception that I was talking about, even when they weren't even designed to be apprehending number, which kind of maybe adds further weight to this kind of this idea that numerical perception, as it's implemented in us, is kind of a natural way of apprehending number, even in other systems.
Thank you.
Thanks, Irina. Good to see you.
Are there other questions? Somebody, Veronica, yes, please.
Hello, you hear me?
Yeah.
So, Max, congratulations on your talk. More or less about the end of the presentation, you touched on the subject of how we could perhaps try and compromise between those sort of unpleasant consequences of the views like Platonism and stuff. Now, I come from a virtue-based epistemology background. And one thing that crossed my mind at that point is that, you know, perhaps a way of compromising would be stating that expert mathematicians have a special skill, like a different virtue, a different skill. It's not that their perception is different, is that they have a different type of skill. In this way, we don't have to bite into perhaps at least some of those unpleasant consequences. So I would love to know if somebody has already thought of that, or perhaps what you think of that. That makes sense.
Yeah, so I think I'm actually very, so I think there's sort of two things there. Firstly, I think virtue epistemology is a really good way to go in, and that maybe it is a kind of approach that the kind of access problems that Ben Asraf's worried about kind of what he wasn't even considering that as an option. But I do think it does kind of undermine this idea insofar as we think that there are links between the epistemology and the ontology, which is kind of where the access problems come from. If we then have a different picture of the epistemology of some aspects of mathematics to others, then it might mean we end up with a kind of a varied view on the ontological claims with regards to mathematics. Now, I don't think that's a problem in itself. It's one of these ways in which we might have to give up on a unified semantics or a unified ontology for mathematics. And I don't think that's a problem. I mean, there are people who've very much advocated for that, where, you know, for example, I think Mark Collivan, building on some of Quine's work, has argued that, well, look, we can just distinguish between applied mathematics and recreational mathematics. And it might just turn out that so-called recreational mathematics, which is actually a vast amount of what mathematicians do, just isn't meant to be sort of coming with ontological commitments. And that might be fine. And so you might make a similar move and just say, well, there's the basic mathematics, maybe not even mathematics, basic numerical capacities of humans, human infants and animals, and that tells us one thing. And then there's the kind of thing that people do in the classroom, and then there's the kind of thing that people do as professional mathematicians, and they might just be seen as very different practices. I just think that does undermine this kind of idea that we have a unified semantics and ontology for mathematics. You know, that it seems weird that when one person says the word three, they're kind of saying something different depending on their own mathematical background or something like that, or the way that they've acquired their knowledge. But I take it, you know, that is a really live option and might be a more reasonable one.
Julian?
Hi, Max. Thanks for the presentation. I have a quick question about the distinction about naturalism in mathematics, about the internalism, naturalism, and externalism. It's what do you think about the possibility of using the idealization strategy? I think in this Maddie sense, Penelope Maddie recent works, for example, Enhanced Determinism, in papers like that, about the use of idealization by the external naturalism in the way to bridge the gap and number from numerosity to numbers. It's an impression that at least for me, is this way are open of, or at least the possibility of this way for develop this gap, this metaphysical parity that you pointed in your talk. At least
Good.
now, thanks for the presentation again.
Yeah, that's really interesting. I guess I'm really interested in sort of more broadly what from the externalist naturalist point of view you might say about things like idealization. And I think one of the things that is sort of surprising about a lot of the work on this stuff in the cognitive sciences is they don't really talk about abstraction or idealization very much. And that's particularly strange if we think about things like, I mean, the whole neo-Phrygian approach within philosophy of mathematics where abstraction principles are really important, right? So actually there's a whole different story that could be told about exactly how we understand things like idealization and abstraction. And I guess, you know, that in some ways, right, colors are in a sense abstract. When people, you know, they're a classic example of abstract entities that people often use, at least when they're sort of teaching Plato or Aristotle's debates to students. The easiest thing to go to, you know, you never see the color blue, you see a specific color blue. And I think, you know, actually it might turn out that when we think about abstraction and idealization, this idea that what we perceive in a way are abstract objects, or what we talk about when we talk about our perceptions are always kind of idealizations from those perceptions, is a pretty good way to go. I'm not familiar as much with the more recent stuff of Muddy's on with respect to numerosities, but yeah, I mean, I think that idea seems to be a good way to go and might be a way of kind of bridging the supposed gap. But I just think, again, it's kind of, there's this kind of sense which then we need to go, well, what are we talking about when we talk about idealization or abstraction? Is this something that we get from asking the mathematicians what they consider abstraction to be, which is more the kind of line that you get when you go down the route of neo-Phrygians? Or do we need to then take another kind of externalist naturalist point of view where we have to come up with a description of what kind of cognitive processes abstraction is? And again, that might be something that can be perhaps more compatible than the kind of division that I've shown here.
Okay, more questions? Well, I have a question, Max. I personally, I follow the externalist approach to these questions, yeah? And I think it's very relevant to analyze all these infant experiments, animal experiments, to get a grip a bit on the basic entities with which mathematicians work, yeah, to understand philosophy of mathematics. And I think also the question of perception is tantamount, is very important. And I agree with you that it shouldn't be seen so separate, questions about philosophy of perception from philosophy of mathematics, because in a way, at least, ontogenetically, it's somehow we acquire mathematical knowledge or number knowledge in some way. But for example, infant experiments and animal experiments about precise numbers or precise numerosities, they're rather limited to go up to 3. Yeah. Then of course you have the estimation, yeah, and then comes in the theory about the number sense. But if you just look at the precise numerosities or numbers infants and animals can distinguish, it's rather limited, and it seems it's like you're importing a very heavy machinery like numbers or even numerosities, which have, it's an infinite structure to explain, you know, say infants being able to distinguish one dot from 2 dots or from 3 dots precisely, because that's kind of what you concretely have. And then, for example, if you look at affordances, yeah, you can say, okay, you have a stimulus, and what affordances, what does it afford the child? Yeah? You could, for example, also make an argument and say maybe, well, if a child sees 1 dot or 2 dot, well, 2 dots affords a choice, yeah, for example, for the child to kind of to focus on 1 or 2. So it might perceive a different affordance in this sense, or it might, the child might, when you talk about sequential attention, yeah, it's different patterns of sequential attention, and these also maybe transfer between modalities. So in a way, you could go a bit against this argument. This goes, no, it can't be about pattern recognition, because in the auditory modality you have also vision modality. So if you, for example, say that that it's about the perception of patterns for sequential attention, maybe you don't have to actually take the step and go that it's related to number. And there's another thing I'm wondering about, what I've been thinking about, and I would like really to have a bit your opinion on that. For example, there's a difference, I think, between when you're saying that an infant reacts to something or what it perceives. Yeah. For example, you can have pitch perception with infants, and you can play a stimulus of a frequency of 1,000 hertz and say 300 hertz. Yeah, and the child will react to the difference. Yeah, and if you have a very young infant, or if you have 8 months, they actually can. They have a certain Weber fraction of reacting to different differences in frequency. I think it's about 2%. Yeah. So they react to these different frequencies, but from the point of view of the experiment, he is engineering a purely quantitative stimulus, in the sense that it's stimulus that only the different stimuli, the only way they differentiate themselves is in a quantitative variable, yeah? in the frequency. But you wouldn't say that a child has some kind of continuous magnitude system or perceives a continuous magnitude. It perceives pitch. The child perceives pitch. Although the stimulus is engineered because you have a wavelength, and what you engineer is a continuous variable. Yeah. And in a way, you could almost make a similar argument. Yeah. I'm thinking when you talk about engineering, say 20 dots or 10 dots, yeah, in front of the child, yeah, and you'd show them 20 dots, 10 dots, and in the end you're engineering continuous magnitudes that and then you have to ask what the child really perceives. Yeah, is it really, for example, if it sees 1 dot or 2 dots, it might perceive a choice, an absence of a choice, or a choice. And what does a child perceive? I think it's the paradigm, I feel, in the cognitive psychology is very representationalist. Yeah, so they almost always say, it represents. Okay, I have manipulated this in the stimulus, so it must be, the child must represent this. But this representation is sometimes a bit vague. What is really a representation? I'm not necessarily anti-representationalist, but I think it has to, I feel there's some more things to be thought about. And I was wondering if you've thought about it, what you think about this. Yeah.
Good, that's really helpful. I mean, so I guess elsewhere, so I cited the Clark and Beck paper, and they talk about this quite a lot in there. It's a recent behavioral and brain sciences article, so it's got lots of good responses to it. And alongside some other anti-representationists, we gave a response where we were trying to sort of push a more anti-representationalist line. One thing I'd say, though, kind of leaving that to the side for a second, is I just don't think there is consistency in terms of how we talk about the represented quality and the representation across all these different things, because we do say that the baby distinguishes different pitches, even when they can't discriminate the kind of pictures that we're talking about, right? So we'll say that this baby is able to discriminate, you know, middle C from E or whatever it is, even if they can't discriminate middle C from D. And yet we're still using that language of pitch, which we take to be more objective there. Whereas in the case of number, that it is quite unique in having that we have what is being represented is not number, but numerosity. And I just think that there's some inconsistency there where, you know, in every other context, we don't think that the thing being represented is somehow different because the representation of it is an imperfect representation, right? Obviously, I can imperfectly represent all manner, presumably all of my representation of the frequencies of energy in the world is to some degree imperfect. But that's not a reason to thereby think that there isn't that more, you know, that the thing I'm attempting to represent isn't the precise thing. So, and I just think that there is this inconsistency that's quite unique to the number case, because we don't talk about weightosity or pitchosity or brightnessosity. We talk about them as if they are these things out there in the world. You know, brightness is a thing that's out there in the world when it comes to light, even though our representations of brightness aren't precise. So, but I think that only touched on part of your question, and I do think there's a lot to be said about actually once we turn to things like affordances, where what we might be detecting is more something that's partly about ourselves as an organism rather than purely kind of mind-independent stuff. And I think that's where things get quite interesting. I mean, the reason I turned to affordances in my work was just because I do think there's a sense in which mathematics has always had and is, you know, quite openly about action. When you think about the roots of mathematics, it's all about what you can do with things, or what you can do, particularly when you think of geometrical cases. And look, once we're talking about action, then we're no, you know, things, we're not talking about objective things out there in the world, but then we're also not talking about things that are purely mind dependent, right? You know, what choices you can make is a kind of both about you and about what exists. And so I think, you know, this is what I kind of hinted at with this idea that actually maybe we need to turn to something like more like thinking of mathematics as a science of action, but that's something I haven't been able to get into in enough detail, really.
Yeah, thanks for the response. I think it's an interesting. I think I feel with the approach with affordances, there's a lot of which you have proposed there. There's a lot of interesting things still to do, I think, in this direction. I see that somebody still raised their hand. João, or was it by chance?
I have a question, but I don't know how to formalize that question again. So maybe I need some help. When we talk about that,
if you want to ask it in Portuguese, and then I can translate it. If you wish.
Sim, por favor, obrigado. Eu consigo escutar em inglês, mas falar não é tão fácil assim. Eu queria saber, porque pelo que eu entendi, a gente cai muito na questão do relativismo e da possibilidade. Quando a gente entra dentro do relativismo e da possibilidade, tipo, a gente tenta achar bases seguras. A forma como a gente já chegou na física hoje em dia, ainda, tipo, essas perguntas sobre a matemática, quando a gente fala sobre a possibilidade, eu caio de novo dentro da física e sobre experimentos que dá para ser montados com essas coisas. Hoje em dia, dado a como que a gente chegou na parte da física, que né, muita partículas subatômicas, muitas coisas, tipo, os experimentos hoje em dia parece que estão ficando cada vez mais entre o ser e o tempo e as pessoas que estão dentro daquela experiência. Como que a gente hoje em dia acha bases seguras para montar experimentos dentro da física e como a gente analisa coisas físicas para ir para a matemática, sabe? Tipo, ele fala muito sobre a percepção do universo simbólico. Como que a gente, tipo, parte do universo simbólico, da parte da representação, para uma base segura que dê para a gente montar experimentos da realidade para ir mais adiante? Tipo, na forma como a física está hoje em dia, como que a gente consegue utilizar o estado da física que a gente está para dar o avanço nessas questões que a gente está estudando?
Okay, let me see if I can translate this. Well, it's related to let me see. So how can you formulate physical experiments? It's related to physics, yeah. So I don't know if I've got your question very well.
May I help, Alex?
Yeah. Maybe you can help me, Irina.
I think the idea is that sometimes when we have no way out in mathematics or we have some difficulties, we try to get some knowledge from physics. For example, make experiments and stuff. So the question is, how can we connect the two things? That's how I understood it.
Yeah, good. I mean, I think that sort of, in the broadest sense, I think that it depends on so if you think about two different types of internalist naturalism I mentioned, they're actually very different. Right? The kind of Quinean route to thinking about the existence of mathematical entities because of their usefulness in the physical sciences and because of their applications is very different from Maddie's route, where she wants to sort of ask professional mathematicians about the set theoretic hierarchy or something like that, right? So, and I do think really where I came into looking at this was looking at the tensions within Quine's own views, because he, on the one hand, wants to say that mathematical entities are indispensable, but he, on the other hand, wants to, everything else is about just deferring to science, right? Which doesn't really talk about those things at all. So I think, but then the whole, which is always there, is this kind of only ever deferring to physics as our most advanced and successful science. So my colleague James Ladyman, I often have arguments with about this, who wants to kind of say that we need to defer to the sciences when it comes to ontology, and then the important thing then is to turn to quantum mechanics. I think that's kind of dangerous in that we have a lot of other sciences, and actually sometimes it's important to think about knowers as much as the stuff that we know about. And so I would say that, the more that you can have integration between mathematics and physics in terms of understanding your ontology, good, but it can't be limited to that. We need to have, to be a proper naturalist, it's important that you're kind of thinking about all of the different sciences and how they integrate with each other. And that's going to involve both deferring to physicists and to psychologists and cognitive scientists. The only thing I would say is that physics is obviously a much more successful science, and most of our current understanding of the mind is probably wrong. So there is a good reason to think that we should kind of maybe listen more to some of the current best theories of our physics in relation to mathematics. But that doesn't mean that we shouldn't listen to the cognitive sciences at all. And in particular, that's why we've got a lot of work to do, really, because to really get the cognitive sciences to a stage at which they are things we should defer to in any way, it's going to take a long time, because it's just harder. I mean, because human minds and even the minds of very simple animals are incredibly complex things to understand.
Okay, thank you very much. So I think I'll thank the speaker again. Yeah, thanks very much.
Questions as well. It's great
for your presentation. And I think now we go to the second presentation of Bruno Ramos. Yeah.
Okay.
So
I have slides, and so, but I'm in my tablets right now, so I will try to present here. Let me see if I can.
Bruno, you sent me your slides. If you want, I can check.
Yeah, I sent to you by email, and
yes,
if I'm not able, then you please, you can share.
Okay. So you try first, right?
Yeah. Can you guys see the slides now?
Not yet.
No.
Not yet.
No or not yet? I think it's
share the slides here.
And now something is happening. I think you're sharing, but we can't see the slides.
Okay. And now?
Yes, now we can see.
Okay. So let me just see if I can put this on presentation mode.
Yeah.
Yes.
Great. Yes.
Okay.
Yes.
Okay. So first of all, thank you guys for inviting me and for all the people that's here today. My work is on, well, I'm a logician and I'm working a couple now some years after the PhD on dialogical accounts of mathematical proofs and dialogical logic, all this game theoretic and game theoretic accounts of logic, but more specifically with dialogical logics, which is like a particular case of game theoretic accounts of logic. But aside this more technical part of my work, I'm also interested in the philosophical part, which is this current trend in philosophy of mathematics, this idea that proofs are dialogues. This has been has been defended by several authors. The main proponent of this idea in the current literature is Catarina Novais, but we can go back and look this idea also in Lakato's works, like Proofs and Refutations and so on. So I'm interested in this kind of work. And today I would like to talk about a particular question in this issue. And so I will start with this. First of all, here I am assuming as a basic premise the idea that a Wittgensteinian idea that language is a public artifact, is something that we learn with others. We learn by learning some public rules of using language. And the main idea here is that language has an inherently dialogical structure. So primarily, we use language to socially interact with others, and we do this in a dialogue with others. We learn language in this way, and we use language in this way. This is a basic premise. I will call this dialogism, this idea about language, and the idea is that even when we are using language alone, there is also it remains this dialogical structure. This is a basic premise for my presentation here. Okay, we can find this, of course, in Wittgenstein's philosophical investigations, in Robert Brandon's making it explicit, and lots of other works. But taking this as a basic premise, we can ask more particular questions. A particular case of our linguistic usage, an important one, is deductive practice. Is the practice of producing proofs, assessing mathematical proofs, logical reasoning. And we could ask whether our linguistic deductive practice is also inherently dialogical. So, in other words, the question is deduction a dialogical practice, primarily and essentially a dialogical practice that serves primarily to enable a specific type of interaction with others? Of course, when we are in a classroom, a teacher is presenting a mathematical proof to his students, and of course, in these cases, he is in a dialogue with his students. He presents the proof, the students ask questions, and so on. There is a conversation going on. But the question here is more fundamental. We would like to understand whether every time that we are developing this deductive practice, we are dealing with proofs, we are always in a conversation, even when we are alone. This is the question that I would like to investigate here and talk about with you guys. Okay. There are two main views on proofs as dialogues in the literature, as I have said before. So if we go back to the 70s, we can find this idea in a seminal book on this direction, which is Lakatos' Proofs and Refutations. In this book, Lakatos presents to us a rational reconstruction of a chapter in the history of mathematics, but Lakatos is trying to narrate the discussions about Euler's theorem on polyhedra, an important theorem by Euler on polyhedra in the 18s and 70s, and he, in his rational reconstruction, shows to us that the process of production of mathematical knowledge in this particular case, which is illustrative of what's going on in mathematical practice, of course, is very dialogical. So mathematicians produce a proof, and on the other hand, they check whether there are counterexamples to the proof produced. They ask questions. They consider whether the proof is sound, and in this process, they go on refining the proof, improving the demonstration, and this process is very dialogical. So there is a conversation going on between the prover, the one producing the proof. This is an idealization, of course. The prover, the mathematician that is producing the proof, and his audience. Okay, so this is the Lakatos seminal idea, and he presents this idea to us in this classic book by him. And more recently, Katarina Duchiri-Novaes, in her book, The Dialogical Roots of Deduction, she develops this idea in full length and in different directions. And this is a very interesting book. And she is right now the main proponent of this idea, this dialogical conception of proofs, this idea that proofs are dialogues, and when we are dealing with proofs, we are developing a dialogue with others and sometimes with ourselves. Okay. So this, I'm very sympathetic to the idea, of course, but this poses several challenges to us. And one of these challenges, an immediate challenge that is posed by this idea, is the question how to give an account of mono-agent proofs. We need to understand how mono-agent proofs should be understood in this context, in this setting, because of course, when we are dealing with others in a classroom, the teacher is working with his students. Of course, in this case, there is obviously a dialogue going on. But when the mathematician is working alone, and this is the case most of the time, what's happening in these cases? It's correct to say that he's dialoguing with himself. In history of philosophy, several times philosophers have said that thinking is a dialogue with oneself. So we find this in Plato, we find this in Cassirer, in different authors. But it seems to me that this is normally this is just metaphorical. There is no real it shouldn't be understood literally what is said in this situation. But I would like this conception, this dialogical conception of proofs, seems to enforce us to say more, to really sustain the claim that mono-agent thinking, the situations in which a person is dealing with proofs alone, in this situation, what is going on is really a dialogue, an internal dialogue, a dialogue of one person with oneself, and this is what we need to understand, whether we can really support this claim in literal terms. Okay. Please, guys, let me know if you want, if there is something going on, because I can't see you right now. Okay.
Everything is fine for me, at least.
Okay. And the Novai's answer to this question is put in this passage. She says the following: the key notion that allows for the transition from explicitly multi-agent situations to mono-agent reasoning is that of internalization. This is the key word, internalization. Okay. And she asks, is there support for the hypothesis that internalization plays a relevant role in this process? So the idea here is that her idea, and I try to verify whether we have empirical support for this idea, is that when a mathematician is working alone, when he is working on a proof in a mono-agent situation without really dialoguing with others, what is going on in these situations is that he internalizes the dialogical discourse. So he is really dialoguing with himself. Okay, and we need to understand whether we have a justification for this, whether we have empirical support for this claim. Okay. The concept of internalization has been introduced by Vygotsky in several works. This is an important work by him, Mind in Society. And basically, Vygotsky says the following. He claims that the development of every higher psychological capacity, like language, usage, logical reasoning, mathematical reasoning, and so on, problem solving, planning strategies for problem solving, all of this all of these capacities are learned with others in social interactions. So these are social capacities in the first sense. Okay, we have, as human beings, we have the capacity to engage socially with others and to learn how to do these things in this external sense, in this interpersonal sense. And when this capacities in the development of these capacities, we start to internalize this capacity. So what is in the first sense external becomes internal, and an interpersonal process is transformed into an intrapersonal one. So we start to do this by ourselves in an autonomous way. So in the case of language, we learn language with others. We learn language by dialoguing with others, and we learn this capacity to socially interact with others using language. But at one point, we start to use this alone. So the child starts to play with her toys and so on, and she starts to play speaking with her toys and imitating adults' procedures. And so in this second case, the use of language becomes private. So the terminology here is the child starts to use private language, private speech. Okay, and later on this becomes internal, fully internal. So the terminology is the child uses inner speech. Okay, So in Vygotsky's this is a passage by Vygotsky, an operation that initially represents an external activity is reconstructed and begins to occur internally. An interpersonal process is transformed into an intrapersonal one. Okay, so there is this passage from the external to the internal. In Novai's account, what is going on in our mathematical practice is that first we are dealing with proofs by dialoguing with others, and then later on we start to deal with proofs by doing this internally. Okay. Okay. We need to understand whether we have empirical evidence of the internalization of logical reasoning. There are several works in this direction. A classic work is the research by Luria, which was a collaborator of Vygotsky. But a more recent work, which is very interesting, is the work by Marie Cunningham. This is her PhD thesis, looking for logic in all the wrong places. She works with, she investigates the logical capacity of people in rural areas of South Africa, and especially with unschooled people. She compares the logical capacity, the capacity for logical reasoning of unschooled people and people with some, which has been introduced to some regular education. But what she verifies in her investigation is that people in general, unschooled and people that had received some regular education, in ordinary contexts, these people deviate from classic reasoning. So when we test modus ponens, syllogistic reasoning, people doesn't seem to be able to follow this very simple patterns of deductive inference. Okay, and she claims that this is not because people are ignorant. It's not this, but simply because in ordinary contexts people deviate from classic reasoning. So people don't follow the classic patterns of what a good inference is. People don't follow classical logic. Okay, so for instance, in modus ponens, people usually accept exceptions. Okay, and this contaminates their capacity for following classical logic. But when we consider people that have been introduced to some regular education, some formal education, then people start to become able to follow classical logic. Okay, so this shows to us first that logic is not innate. The classical patterns of logical reasoning are not innate, and also it shows to us that classical logic is a cognitive artifact that we learn in school. We learn in formal context of formal education. Okay, so when formal education improves, classical logic emerges. Okay, this is very interesting. This seems to show to us that our capacity for logical reasoning is something that we internalize in some specific context of interaction with others, context of formal education. Okay. But the question remains, we need to, this is a passage from Vygotsky, it goes without saying that internalization transforms the process itself and changes its structure and function. So you still need to verify whether, even if our capacity for deductive practice is something that we internalize in the social interaction with others, we still need to understand if the outcome of this internalization process is still dialogical. Okay, so we need to understand whether the following question: is the internalization of an originally dialogical practice still dialogical? We need to understand whether dialogicality is a feature that remains when we consider the outcome of the internalization of our capacity for dealing with deductions. Okay. To assess this question, we need an understanding of the concept of dialogicality, and we can find in Novaes' work a conception of dialogicality. There are two parts. The first one are criteria that have been presented in the literature by a psychologist, Charles Fernyhough. He has an account of what a dialogue is. It's one of the few accounts of what a dialogue is, of the concept of dialogue. It seems very surprising to me that a psychologist has presented this kind of work, which is very philosophical. And he says two things. In a dialogue, there is a simultaneous accommodation of multiple perspectives. A dialogue is a kind of practice in which we are trying to accommodate multiple perspectives. And also is this kind of practice is always self-regulated. There is no third party externally regulating the dialogue, okay? The participants themselves need to regulate the exchange, the communicative exchange, okay? And the second part, this is from Weiss, is adversariality. She understands that the kind of dialogue that is going on in our proof practice, in our practice with proofs, is adversarial. And more specifically, there is a structure of a game that she calls prover-skeptic games, okay? So I will present these features, and later on we will try to understand whether we have evidence for this, for the idea that the internalization of our dialogical practice with proofs is still dialogical. Okay. First of all, on multiple perspectives, the idea here is that dialogues always involve the accommodation of multiple perspectives, and perspective here is a very broad concept. It's not just epistemological, okay? It can be, a perspective can be a belief, of course, but it can be an emotional motive, it can be a desire, okay, and so on. So every one of these entries that an agent can present in a conversation, a belief, an emotional motivation, a desire that the participant can express. All of these are perspectives, okay, this terminology. And inner speech can be clearly multi-perspectival because there are, for instance, there are tests with children when with 2.5-year-old children that barely speaks, who is learning to speak, and we do tests in which we ask the children we present a model copy of a puzzle, and we ask the children to build the puzzle using the copy. Well, the children are very young, they cannot do this alone, but with mother's guidance they can access the perspective of the mother, and then the children can solve the puzzle. Well, in a dialogue, children of course can access the perspective of others, but this test showed to us that later on the children start to imitate the mother, so they become autonomous, not because they don't need the dialogue, but because they can internally reconstruct the dialogue with themselves. So they can internally access the mother's perspective by imitating mother's behavior, okay? So inner speech is clearly multi-perspectival. This is not a problem. The problem is with self-regulation, okay? As I have said before, in a conversation, there is no third party externally regulating the dialogue. self-regulation here needs to be understood in terms of rights and cooperation, okay? So the interlocutors are the ones responsible for maintaining cooperation, okay? And this is self-regulation. They are the responsible ones. And for checking whether a dialogue remains cooperative, okay? Well, this is the problematic feature, because we have at least one argument in the literature, one objection in the literature. This is a PhD thesis by a philosopher called Daniel Gregory. In his PhD thesis, he was supervised by Dave Chalmers, and it's one of the few philosophical works on inner speech. The entry on Stanford Encyclopedia of Philosophy on inner speech is by him. And he has an argument that inner speech cannot be cooperative, cannot be really cooperative. And because of this, consequently, it's not dialogical. And his argument appeals to Greissen's idea about conversational cooperation. According to Grice, cooperation, to be cooperative in a dialogue, is to respect conversational maxims. But Gregory claims that it doesn't make sense to respect a rule, the idea of respecting a rule, if it is not possible to fail in respecting it. And this seems reasonable to me as well. But for Gregory, it doesn't make sense, the idea that we can disrespect conversational maxims to ourselves. So, for instance, one of Greissen's conversational maxims is being truthful. You shouldn't lie to other people. Well, we cannot lie to ourselves. Well, this is very controversial. We surely can lie to ourselves, but and another conversational maxim is be informative in the right measure. And Gregory claims that we cannot fail in being properly informative to ourselves. Well, we can conceive of cases in which it seems to make sense that we are doing multiple functions. We are trying, for instance, we are organizing a party, and we are doing several things. We are performing several roles in this management process, and one of these roles we generate information, but we generate less information that we should provide. And then later on we discover this. Well, I have performed badly in the first role. So this can happen, and Gregory doesn't consider these kinds of cases. So this is very controversial for me. It seems to me that yes, inner speech can be really cooperative. It makes sense to say that in inner speech we can fail in be cooperative to ourselves. So so these two features, the accommodation of multiple perspectives and self-regulation, these two features can happen in inner speech. Okay. And the third feature, prover skeptic gaming, this is Novaes' idea that in deduction, as a dialogue in deduction, we have the structure of a partially adversarial game between a prover and a skeptic. So in deduction as a dialogue is a game between two participants. The first one is the prover, who generates the proof, and the second one is a skeptic, who searches for possible counterexamples, asks for clarification, and there is a loop. So the prover, based on skeptic's demands or what the skeptic verified about possible counterexamples, the prover refines the proof, try to improve the demonstration, and this is a loop, of course. Okay, so Novaes understands that this is happening in deductive practice as a dialogue. Okay, so in sum, and this is just a joke, guys, deductive dialogues are something like this meeting could have been a duel. Okay, this is a meme that I found in the internet. So from this perspective, when we go to the monoagent case, so from this perspective in monoagent proofs, what's going on is that the mathematician dialogically fights himself or an internal persona that he also enacts, okay? So this is the idea. First, as dialogues, deductive practice is a dialogue with others, so and it's okay, there is no problem here. But when we go to the monoagent case, then the dialogue internalizes and the mathematician starts to dialogue with himself, and this dialogue is adversarial, so he's fighting himself or an internal persona that is an antagonistic in this process, okay? Okay, so the question is, this is what we have seen right now is just an account of dialogicality, is Novaes' account of dialogicality. And now we need to understand whether there are empirical evidence supporting the idea that monoagent proofs are internal dialogues in Novaes' sense, okay? And it seems to me, this is my claim here, that it seems to me that the answer is yes, we have empirical evidence supporting this idea, okay? But the empirical evidence, we need to go to the literature in mathematics education to verify whether we have evidence supporting this idea. And different works in mathematics education show to us that the process of learning mathematics is a process of internalizing teacher's perspective. This is quite different from what Novaes says to us in her book, because in her book, she says that, let me just go back a little bit. She says to us that it is the skeptic that is being internalized in the process of learning mathematics, okay? So when we go to the multi-agent situation, to the mono-agent situation, when the mathematician starts to working alone, he is internalizing his audience, and the audience is the skeptic, okay? Is the audience who puts questions, who searches for counterexamples, okay? But what we learn from the literature in mathematics education is that things go in the other way around, okay? So first of all, the student is the audience of a proof. In a mathematical classroom, the teacher is presenting the proof, and the student is trying to keep track of teacher's presentation. But when he starts to learn mathematics, he's internalizing the teacher's perspective, and the teacher's perspective is the prover's perspective. It's the perspective of the one producing the proof. So it's different from what Novaes claim in her book, okay? So what this literature showed to us is that in learning mathematics, the students internalize teacher's perspective, and this perspective is the perspective of a person presenting a formal theory. The teacher is presenting definitions, deductive patterns, strategies for solving mathematical problems, in sum, the formal theory, okay? And in this process, the student is not replacing his original perspective with the perspective of the teacher. He's trying to accommodate his own perspective, his own informal perspective on mathematics, on mathematical concepts, and with teacher's formal perspective, okay? The student's perspective are important because it's the student's perspective that provides objectual descriptions of the objects that could be relevant for mathematical thinking, okay? So these two perspectives are important, and in learning mathematics, the student needs to accommodate both standpoints on mathematical concepts, on the universe of mathematical objects. Okay. So to learn mathematics is to become capable of accommodating these two perspectives. The student must learn a formal theory on the one hand, and on the other hand, he needs to exercise his original capacity for imagining situations and objects. Okay. Just to give an example to you guys, this is an example by this author Barvel. Learning the concept of polygon. It's a very simple example. He presents the case of a teacher who is teaching mathematics to students, to foreign students that who are going to France, going to Canada, and they don't know French, but they are learning French, and at the same time they are completing their basic formal education. So the teacher is presenting to them in this classroom meeting. The teacher is presenting to them the concept of polygon, and she wants to understand whether the students have understood what a polygon is. So the teacher asks to a student, in which column did you put C in? And the student says, he put the polygon, that object in the class, in the collection of the non-polygons. Okay, so teacher asks, non-polygon, why? The student says, because it is not a straight line. This is the informal description that the student is providing of that object. Okay. And the teacher continues, it is not a straight line. The line is curved. Look, I will write it here for you. A line can be straight or curved. Okay, well done. So the teacher is presenting the formal terminology, the formal concepts, the formal theory on polygons. Okay. So both aspects of the mathematical education are presented in this passage. Okay. I should have been included another slide, which is related to what you guys were discussing in Mark's presentation. There is an important philosopher of mathematics and also a theoretician on psychology of reasoning, which is Annie Svart, and she says that there is an interesting book by her, Thinking as Communication. It's about philosophy of mathematics and also mathematics education, the psychology of reasoning. And she says that there is a difference between our original informal approach to mathematical concepts, in which we understand that mathematical concepts, we understand mathematics in processual terms. So, for instance, children start to learn mathematics by counting. And in this case, there is no reference to objects. There is a practice of counting. But later on, we start to make reference to certain objects that have been appeared in that original process of counting, even by abstraction. At this point, we need an ontology of mathematical objects, of course, but there is this difference between a first approach to mathematics, which is very processual and in probably arguably not referential, and a second approach which is referential. Here we could say that this difference between these two moments is the difference between an informal original approach to mathematical concepts and the formal approach that students are learning with their math teachers. Okay. This comparison of perspectives is self-regulated. So the formal perspective is important because it is responsible for establishing logic, axioms, and definitions. And this is the prover's perspective, as I was saying before to you guys. And also the informal perspective, the original student's perspective, is also important because it is responsible for verifying formal soundness. So, and this is the skeptic's perspective, because of course we can learn a formal theory, but we can only be sure that the formal theory is informally sound if it is compatible with the way in which the important objects appear to us and appear to us in the informal perspective. So, of course, we can say that Euclidean geometry is formally sound, okay, because there is no contradiction in the axioms of Euclidean geometry. But this is not enough. We need to understand whether it is also informally sound, and it is informally sound because it is compatible with the way in which the objects, the Euclidean figures appear to us. So, and of course, if we start to consider non-Euclidean objects, then the incompatibilities appear, and then in this broader setting, Euclidean geometry starts to become informally unsound, informally incorrect. Okay, but it is important, this exchange between the formal perspective of mathematics and the informal perspective. And this is what Lakatos says to us in Proofs and Refutations. Of course, this is and for Lakatos, this is important for producing real mathematical knowledge. So here I'm supporting and I'm opposing strongly to formalist accounts of mathematical knowledge, of course. So just just concluding this part, so the literature in mathematics education suggests to us that first, mathematical thinking involves the accommodation of a formal and an informal perspective. Okay. These perspectives fulfill distinct roles in a self-regulated exchange. This exchange is cooperative, but these perspectives play different roles. The formal perspective plays the role of introducing formal theory, and the informal perspective plays the role of guaranteeing informal soundness. And these roles are very similar to the structure of the prover-skeptic game, because the formal perspective is the perspective of the prover, of the one introducing formal theory and the proofs and so on. And the skeptic position, and the other position, the informal perspective, is the perspective of the skeptic, who is trying to verify whether the formal theory is compatible with the objects that appear in the informal perspective. Okay. Okay, this is the main part of my presentation. Just to conclude, so I have said to you guys that if we go to the literature in mathematics education, in the literature in psychology of reasoning, we can find strong evidence that Novaes accounts, Novaes dialogical accounts of proofs is correct, is compatible with the empirical evidence. But I would it's something that also interests me. I would like to know if we can find phenomenological evidence in favor of Novaes accounts. Okay, phenomenology is just very quite briefly. Phenomenology is a study on the reflexive structure of our thinking. So mathematical thinking is intentional. It's directed towards mathematical objects. And in phenomenology, we are trying to analyze this structure of intentionality, not the objects themselves, but the structure of being directed toward objects. And we say that this kind of investigation is reflexive because it abstracts from the objects and go to the intentional directionality to objects. Okay, and And phenomenology does this by analyzing self-reports, the reports that people provide, in which they are trying to describe their experience of being directed toward objects. And Novaes also has a paper on this from 2016, in which she analyzes self-reports on people's experience with reduction proofs. Quite briefly, reduction proofs are proofs in which to try to prove not P, we assume P. So we start by assuming the thing that we want to prove that it is false. So it's cognitively demanding to work with these proofs, and part of the studies on reasoning from psychology and from philosophy try to understand why it is so cognitively demanding. There are two phenomena associated with our experience with proofs by reduction. The first one is belief bracketing. We need to suspend judgment on provisional hypothesis. So when we to prove not P, we start by assuming P. Well, we start by assuming something that we want to prove that it is false. So of course we do not believe in this assumption, and so we need to suspend judgment. We assume without believing, and this is kind of strange for the person dealing with the proof. And further on, there is doxastic conflict. We need to assume things we consider false. So to prove not P, so I want to prove that not P, so I believe that not P is true, and I start by assuming the opposite. I start by assuming that P, so I start by assuming something that I believe it is false, and this is even more difficult from a cognitive perspective. So for psychologists and for philosophers, we want to understand why it is so cognitively demanding, what's going on in these cases. And Novaes considered the case of Mariah. She provides the following report on her experience with proofs by reduction. I cannot pretend that it is true. I cannot tell myself such a lie and believe it true. So in this phrase that is, I have taken it from a passage in which she's trying to describe her experience with this kind of proofs. And the first part, I cannot pretend that it's true, there we can identify belief bracketing, because when she says that she's pretending, she's pretending that she believes P. She's assuming without believing, and this seems to her that she's pretending, and when she do this. And the second part, I cannot tell myself such a lie. Here we have doxastic conflict. Well, lie is to say something that you believe is false. So there we have the other phenomena, doxastic conflict. We only have this in the self-report, but based on this, Novaes claims that the dialogicality of mathematical thinking is the best explanation of what's going on in these cases. This seems to me quite speculative, because notwithstanding, these reports do not directly inform the experience of inner dialogues. Okay, in no part of this passage is Mariah saying, or in the full interview, in no passage is Mariah saying explicitly that she experiences to be in an internal dialogue when she works with reduction proofs. She's not saying this. We are inferring this from what she says, because following Novaes, we understand that this is the best account of what's going on in these cases. As I have said before, I'm quite sympathetic to Novaes' dialogical conception of proofs, but from a phenomenological standpoint, we still need a better account of the dialogicality of our mono-agent proof practice. So right now we don't have a fully developed phenomenology of the dialogical characteristics of our practice with proofs. Okay, and this is something that I would like to have in the future. So that's it. Thank you, guys. I would like to dedicate this presentation to my father, who passed away some days ago, and that's it.
Thank you very much, Bruno. Other questions? Yeah, Arthur, if you want to ask a question.
Yes, I have a question. First, congratulations for your presentation, Bruno. I don't think I really understand your thesis, but I tried to make a paradox to see if I understood it correctly. From what I understood, you have two conceptions of dialogue: an external conception and internal conception of dialogue. So I tried to formulate. I don't think it's a problem. It's more like, for me, an interesting point of view of your presentation. If a deduction is a dialogue, and a dialogue can happen, can occur in your head and in a mathematical proof, if you're writing your reasoning, so there are there two types of dialogue occurring at the same time: the one that it happens in your head and the one that you're writing. Is that correct?
Yeah. No, my claim is a little different, but thank you very much for your question. My claim here is a little different. What I'm saying is that from this perspective, from this dialogical perspective on proofs are not something that primarily we do by ourselves. We do in a dynamics with others. So in this dynamic, this discursive dynamic is a conversation, is a dialogue that we develop with others. And when we start to do mathematics by our own, when we think mathematically, when we deal with proofs in mono-agent situations, that I have said, then in these cases, the dialogical feature remains. We still have a dialogue, but a dialogue with oneself. Okay? So in this case, the mathematician is also dialoguing, but his dialogue is internal. He's dialoguing with a fictional antagonist, and if this is correct from a technical point of view, from the point of view of logic, we need to have different frameworks for dealing with this. So today, in the mainstream philosophy of logic, we have game theoretic accounts of logic. For instance, dialogical logics. There are several systems of dialogical logics, but they are seen by the community as a curiosity. They are not seen as something that should be considered as a main framework for doing proof theory, for instance. Okay, and from the perspective that I'm presenting here, from this dialogical perspective, things should be put in the other way around. So if proofs are primarily, from a philosophical standpoint, if they are primarily dialogues, then we should prioritize dialogical accounts of logic. For instance, some system of dialogical logic. Okay.
Okay, thank you. Julia?
Hi. First, thanks for your presentation, Bruno. And I have a question about this idealization of this ideal nature of internal dialogues in mathematical reasoning, in deduction, in more general, in account that you present to us. The question is, when the dialogue in this context does end, when the skeptic and the prover persuaded by point, by theorem, by proof about the statement. It's a finite or infinite process, potential infinite process of argumentation, of dialogue.
Yeah.
I have a little curious about these characteristics of these of dialogues.
Yeah. Thank you for the question, Julian. Yeah, this is a very interesting point because from this perspective, we have from the epistemological point of view, the dialogical accounts of proofs commit us to an idea that proofs are defeasible. Okay, they are always defeasible. Okay, so we don't have the point in which the ending point in which mathematical truth was achieved with certainty. Okay, Lakatos says to us that the process of production of proofs is quasi empirical. I don't know if we need to commit to this. This is much more strong, but certainly the process of producing mathematical knowledge is defeasible, and we can always be wrong about what we, at least in principle, of course, about our mathematical theorems and mathematical proofs. And this is very quite interesting because right now we have this current trend in mathematics about the use of proof assistants and automated proofs, and we have strong systems for automating proofs like Lean, like Coq, and so on. And there is this trend of trying to formalize proofs, mathematical proofs, in these systems. And sometimes a more naive standpoint could say, well, when we formalize all mathematical theorems, then we will achieve mathematical certainty. And I don't think so. I think that even in these cases we have mathematical defeasibility. Okay, so it's a very interesting point on epistemology of mathematics.
Okay, are there other questions?
Okay. So thank you, Bruno, for this great talk. I have two questions, maybe because I didn't understand everything you said, trying to make sense of this mono how do you say?
Mono
agent proofs.
When we are thinking a lot.
The first question is, why you mentioned deviations from classical logic in ordinary contexts. So why deviation from classical logic in ordinary context should work as an empirical evidence for internalization of logic? Maybe someone could just say, okay, classical logic is not innate, but other logic is. Okay. I don't know, maybe it's a possibility, but it's my first question. The second one is, Can
I answer this question first? Yeah, I mean, my point here is not that perhaps we have a basic core logic and which is innate, and I'm not putting pressure on this point, but what this kind of research showed to us is that the classic patterns of deductive practice which is encoded in classical logic and perhaps standard set theory and so on. And this is not innate. This is learned. We learn this in some specific situations in being introduced to formal education. So, and more interestingly is that in ordinary contexts we don't use this kind of cognitive tools that we learn in formal education. We only use this if we recognize, well, this is a situation in which I should use this kind of cognitive tools. Okay, so classical logic is quite specific. It's not. I'm a classicist from the perspective of the philosophy of logic, but I think that classical logic has a special place in science, but it is not innate and it is not of universal usage.
Okay, so thank you for the clarification. My second point is, again, something that I probably didn't understand. It's about the doxastic conflict as a best, maybe it's a best explanation for, again, the internalization and this idea of proof as dialogues. But of course, you can see reduction as, you can explain reduction in many different ways, like by using modal semantics, by using impossible words, many different approaches for just in a semantic perspective. So I'm not seeing why this is the best explanation for doxastic conflict, you know?
Yeah.
Maybe.
No, I'm totally with you on this, because it seems to me that there is a lack of evidence for saying for Novaes' claim there. It seems to me that I think that she saw in this passage something like, well, the subjects are saying that they feel a dissociation between their beliefs and the assumptions they need to make in the proof. Okay, there is a dissociation, but this falls short for saying that there is the consideration, that the attempt to accommodate multiple perspectives. So it seems to me that there is a lack of evidence there. We need more research on this direction to conclude, to achieve the conclusion that she's trying to achieve, right? So I agree with you in this.
Okay, maybe a last question. I see João.
Hi.
Okay, I suddenly have. Okay, I see suddenly three hands. But okay, João, please go ahead.
I'm trying to be quick. When I think about multiple perspective, I think if culture can be a line for accommodate different perspective and reduction. When we bring culture to the table, and we have some more illuminance. Vou tentar falar em português, porque daí fica mais fácil. E daí, por favor, alguém depois possa traduzir em inglês pro pessoal em inglês também conseguir entender. Mas assim, quando minha questão que me surge é, quando a gente tenta acomodar diferentes perspectivas, eu queria saber se a cultura pode ser um ponto importante para a gente pensar sobre isso. O que eu fico pensando sobre essa normalização da lógica é, quando a gente pensa sobre o formal e informal, a gente parece que está pensando sobre dissonância e consonância. Quando a gente pensa sobre dissonância, tem essa coisa de lutar contra si mesmo, e isso coloca uma certa dor. Então, me parece que o pensamento o monoagent, o scapt agent, acaba indo para a questão de uma dissonância do indivíduo conforme o ambiente que está ao seu redor. Quando a gente fala sobre formal, classic e tudo mais, a gente está falando um pouco mais sobre harmonia, sobre essa coisa da cultura. E daí parece que tem um pouco sobre a questão do empirismo. O meu ponto que eu entro sobre isso é, quando a gente está falando sobre essas estruturas lógicas, a gente parece que está falando sobre a acomodação do indivíduo a respeito dessas múltiplas culturas de uma forma harmoniosa dentro de si. Isso me leva ao quê? Eu tento pensar sobre coisas mais específicas e pontuais, como, por exemplo, por que hoje em dia o suicídio é tão normalizado? Tentando pegar sobre a coisa do Ramos e tudo mais. Me parece que essas questões são sobre uma estrutura lógica que a gente faz dentro de si mesmo, a questão dos sentimentos. Quando a gente está numa estrutura lógica consonante, uma lógica formal, uma clássica, com consonância com as pessoas ao nosso redor, e está seguindo uma determinada tradição, a gente meio que vai seguindo em um determinado período. Se a gente vai para a cultura, me parece que a gente acha um ponto de obviedade. Pessoas dentro da mesma cultura têm a mesma obviedade, parece que elas compartilham da mesma lógica. Eu gostaria de saber se essas normalizações a respeito de diferentes coisas poderiam ser um exemplo prático para, tentando trabalhar a respeito da lógica que a pessoa tem consigo mesmo, se a gente consegue diminuir questões como, por exemplo, essa normalização do suicídio que a gente tem hoje em dia, porque parece que muita gente está dissonante, porque não consegue fazer uma consonância da cultura ao seu redor, e daí fica nesse skeptical cotot, fica no pensamento skeptical tentando achar linhas de fuga e sempre não encontrando. Então eu queria saber se, quando a gente fala sobre o empirismo, quando a gente cai nessa coisa da cultura e da obviedade da cultura, se trabalhar com a lógica nesse sentido pode estar muito relacionada a essa questão. Eu queria saber se faz sentido pensar sobre isso. Se quando a gente está pensando sobre a lógica formal e sobre a lógica informal, se isso a gente pode conectar os afetos do indivíduo consigo mesmo, e se pode ser e se trabalhar dentro da lógica, pensando nessas questões sobre diversidades culturais, nesses conflitos culturais que a gente tem, isso pode ser um caminho para, através da lógica, e se dentro da lógica a gente não está tentando acomodar isso, esses diferentes conflitos culturais, e que quando a gente percebe que a nossa lógica não está muito bem acomodada e que estamos em constante conflito com nós mesmos nessa skeptic monoagent, se a gente não acaba indo para esses pensamentos mais dolorosos, tentando sempre acomodar isso, e em algum momento parece que a gente sempre cai dentro de questões tradicionais. E só quando a gente cai dentro de questões tradicionais e assume uma lógica clássica, ou uma lógica que faça sentido para as pessoas diretamente ao nosso redor, a gente acaba tendo uma consonância. Então, eu gostaria de entender se essa parte do formal e do informal dá para conectar a consonância e a dissonância de um indivíduo com relação ao seu meio. E se isso faria sentido como um modo de trabalho para tentar reverter essa normalização do suicídio que a gente tem na questão da sociedade. Isso, não sei se é um pensamento muito abstrato, mas me veio um pouco à cabeça. Porque quando a gente fala sobre essa coisa da formalização da lógica dentro de nós mesmos, o indivíduo num exercício muito solipsista, a gente parece que cai nesse abismo, onde a gente, não sei, onde parece que muitas pessoas não conseguem internalizar uma tradição, uma coisa clássica, e o empirismo dela ao seu redor, muitas vezes nesses conflitos culturais, fazem com que a gente acabe indo para um caminho muito dissonante de tudo. Então, gostaria de saber se essas questões sobre formalidade e informalidade podem ser conectadas a esses ciclos dos afetos individuais do indivíduo com relação ao seu meio.
Yeah, well, lots of things. It seems to me that, yeah, of course, there is this exchange between an informal perspective and a formal perspective in the production of mathematical knowledge. And there is also a discussion about mathematical culture, like culture, ways of doing mathematics, patterns of proof, what is considered a good proof, and this can vary, historically vary. If we go to the history of mathematics, it varied between eras, and yeah, of course, there is this pressure of the culture, of the way in which we do mathematics, and this can vary. This is not fixed, and also inside a mathematical community, we have different perspectives of what counts as a good counterexample, what needs to be considered, and so on. The Lakatos book, Proofs and Refutations, shows lots of examples of real historical examples in this direction. But this possible conflict between the standpoint of an individual and the standpoint of the community, this is not a problem for mathematical knowledge. But this can be also considered an essential aspect of the production of knowledge, not just in mathematics, but in any science field. So about suicide, I cannot say anything, of course, but on this possibility of conflict between the standpoint of the individual and the standpoint of the community, of the scientific society, and so on. Yeah, this is a fact. This is something that can happen, and it's not a problem for mathematical knowledge. It's something that we need to embrace and consider in our investigations about philosophy of mathematics. Yeah.
Okay, thanks. The thing is, there's still two hands up here, but we are a bit gone over time, and the plan was just to have one more question. Would it be possible to I don't know, go on, and maybe later you can communicate via email to ask the questions, because not to go too much over time. Would that be possible, Irina or Gabrielle? So that we
I have a super quick question.
Okay, well, it's super quick, then I think it's okay. Go quickly.
Just out of curiosity, which type of logic is considered more natural or possibly innate?
Possibly innate. Oh, okay. No, yeah. As I have said before to Guilherme, I don't. It seems a very hard question. I mean, I know that a lot of people here in Brazil and abroad wants right now to consider these questions about the adoption of logics and whether there is a natural logic and so on. I suspend judgment on this. I don't know if there is a natural logic. Well, we have a natural capacity for learning logic and for engaging in logical practices, in practice of producing proofs of logical reasoning and so on. But I'm not sure if there is a natural logic. If I should bet 2 cents on this, I would say that there is no natural logic. But I know that this is a very tough question, and I just avoid being judgmental here. And so I would say that it's certainly not classical logic. It's certainly not classical logic, because classical logic is associated to ways of thinking that are not natural. So if we for instance, the classical interpretation of the material implication is very non-intuitive and so on. So it's not classical logic, certainly.
Okay, thank you very much. Thanks again to the speaker, Bruno, and all the best in these difficult times. We've been through the same times 15 years ago, so all the best, Bruno. Okay, and now the question is how we proceed. Guilherme, did we want to make a short break, or do we go right to the end? What should we do?
Yeah, I would like to suggest a small fast break, maybe 10 minutes, but it depends on you. If you, Osvaldo is the next one to present. He's here. Maybe he wants things to go on. Then you maybe a break, a 10 minutes break. So just for us to water, something like that. Okay.
Is that okay
so
with
10 minutes?
Yeah. 10 minutes, yeah. So at 11:36, we'll
Okay.
be back here. Okay.
And then come back.
Okay.